down. Wow, full house today. All right, if there's not enough chairs, just grab some of the stools from the back. And if you're still missing some, there's chairs on the side here. So just grab a seat. All right, cool. Thanks everyone for coming down. My name is John, and welcome to the July edition of the Perth Data Engineering Meetup. Sorry, it's a bit of an echo. We have two amazing talks today. The first talk is by David. He's going to be talking to us about Databricks. And the second talk is going to be from Denzil, who will be talking to us about ETL to ELT. So a bit of history and how data engineering has evolved. But before we start, we just want to give some thanks to our sponsors. So thanks to Core for the space today. Thanks to Imply as well for sponsoring the pizza. And thanks to Skills Matter for sponsoring the drinks. So a couple of small little knickknacks that we're going to give out today. So firstly, we're going to give out a 1-year Skills Matter membership. So Skills Matter, if you guys don't know, it's a company that provides training and conferences and things of that nature. Sorry, it's a bit of an echo. So if you just want to get a 1-year membership, there's a draw here. If you just scan that QR code and fill out the form, then you'll be in for the draw. I'll just leave that up there in case anyone wants to. Yep. Awesome. The other thing just quickly as well is that the YAL Developer Conference is kicking off in September. So if you do want to attend that, there'll be speakers from around Perth, people from ranging backgrounds, software engineering, data engineering, cloud. People will just be giving talks there as well. Cool. Without further ado, let's jump into today's content. So first up, we have David. David is an Azure data engineer with a strong background in ingestion, automation, modeling, and governance. And he really enjoys spending his time building new data platforms for customers and taking them along the Databricks journey. Without further ado, let's welcome Dave up onto the stage.
Can you guys hear me without the mic?
Yeah.
Yeah? Cool.
Okay, not quite.
Yeah, but one's hearing's bad. Come to the front.
I'll put this here if you need it.
Cool. Cool. Thanks so much for coming, everyone. I'm Dave. I'm a lead consultant at a pretty new company called Cuusoo.
Sorry, David, it's a bit quiet right here.
Bit quiet.
I'm so sorry.
That's all right.
Thank you.
Mic test.
Test.
Just put it.
Hello? Is that better?
Just put it.
Yeah, cool.
Just put it down.
You reckon?
Yeah.
Hello? No? Not too close to the electronics.
Yeah.
Hello? No, you can't. No, I'll hold it. That's all right. Cool. Yeah, I was saying lead consultant at Cuusoo, pretty new brand in the market. Work for a bigger brand of companies called the Mantle Group. If you don't know how to pronounce it, it's on my t-shirt. It is S-O-O, but it's actually pronounced Sue. And yeah, as John mentioned, I've been an Azure data engineer for probably the last 5 years or so. Like to do a lot more than data engineering, so touch services like functions, do a lot of Terraform, CI/CD, that sort of stuff, and yeah, really been working on Databricks intensely the last year or two. So I do apologize up front. I know governance is not something anyone wants to talk about, but I know it's an important part that people need to do, and yeah. Can I just get a show of hands how many people have heard of Databricks or used Databricks before? Yeah, cool. That's quite a lot, actually. So for those of you that don't know what Databricks is, essentially Databricks coined the term the data lakehouse. Now, a lot of you would be familiar with data lakes and also data warehouses. And it's the notion of bringing the best of both of those together in a single place. So if you just had a data lake, you wouldn't have any sort of transactional consistency. So you wouldn't be able to perform inserts, updates, or deletes on any of your data within the data lake. And that's where Databricks comes in to provide that transactional consistency. So Databricks runs on Apache Spark, which is essentially an open source big data processing platform. And Databricks is sort of your one-stop shop for data engineers, data scientists, and data analysts. So if you've got an existing data lake, it's very easy to ingest that data through the Databricks platform and gain insights into that. It is supported across all three cloud vendors, so Azure, AWS, and GCP. But the talk today is going to be a focus around Immuta. Has anyone heard of Immuta before? one quick. So essentially, Immuta is a governance platform that sits on top of Databricks. So if you want to do things like row-level security and particularly more intense governance, doing things like attribute-based access control, there aren't many options available in the market. Immuta is one vendor that's gone all in with Databricks. Not to say that they only support Databricks, they also support EMR, Synapse, Snowflake, all the major cloud providers. So if you were using any of those tools, you could take Immuta into consideration too. So just a high-level enterprise architecture of what Immuta looks like. So as you can see, in terms of storage, it's any cloud storage that you have across the three cloud vendors. It works with any of the ETL tools that you may have, so cloud native or things like Fivetran or dbt. The compute engine is really where Immuta integrates. So it touches Databricks, Snowflake, Starburst, BigQuery, Synapse, and a whole bunch of others. So if you're working in an environment where governance is of the utmost importance, so the project that I'll be presenting on was in the healthcare industry. So PII data and data sensitivity is very important, which is why we went for Immuta as a tool. So I'll quickly just chat around the three areas of Immuta. So around security, we've got a lot more than just row and column-based access control. We've also got role-based access control, which a lot of you may be familiar with. A very important one is attribute-based access control. So if I wanted to give someone access to a set of tables based on a tag that I'd apply to those tables. So say, for instance, I've got 5 tables that relate to customers. I could go and tag that with a customer attribute and make those tables available to anyone within the sales team, for instance. So it makes that whole governance process a lot easier. It also has something called purpose-based access control, where if you have a short-term requirement to access data that you don't have access to through your governance policies, you can create a purpose-driven policy to allow you access to that data temporarily. From a privacy perspective, it does things like K-anonymization and de-identification. So you can de-identify either using a masking algorithm, or you can do hashing and sort of hash emails or hash telephone numbers based on a set format that you provide. Around data governance, it's really around an interface to easily manage those policies. And governance isn't an easy thing to do at the best of times, but you want to make that as easy as possible, and Immuta really does do that. I might skip over a bit of this quick because I'm super keen to get into the demo. So around the security side of things, we already chatted about the granular access control. You'll see the screenshot on the right has a basic definition of what a policy might look like within Immuta. So a policy can be applied based on an attribute that's been defined or based on a group that people belong to. And it's very configurable in terms of how you can make that policy dynamic. I'll jump over that. So essentially, from an Immuta perspective, you've got 3 user types. So our data users are our day-to-day users within the business who are going to be accessing the data. So they'll be accessing the Immuta UI, which I'll show you guys in a bit. But they'll also be running queries against Databricks to retrieve their data through something like Tableau or Power BI if they wanted to do any data analysis around it. You've then got your data owners who are responsible for specific areas within the business. And they might be responsible for creating policies within their certain area of the business, making the data in their business accessible to the rest of the organization. And then on the highest level, you'll have data governance, who are those people that are going to govern your data assets across the entire organization. So they're going to apply global policies that apply to all data sets and all users within the organization. Immuta has two types of policies. So on the one hand, we have subscription policies, and that defines who can access the data. So you can take an optimistic or a pessimistic approach to subscription. So if your data is very sensitive and you only want to make certain tables available to people, then you can use a pessimistic approach where if someone new gets added to the system, they cannot access any data within the platform. They have to specifically be given access to certain assets within your data platform. Or you can have optimistic where everyone gets access and you apply specific policies to do things like masking addresses or ages or date of births and that sort of thing. And on the other side, we have data policies. And that's really going to define what the end users are going to see. So if we, for instance, decide to mask an email address, we may apply a regular expression to that, so it still looks like an email address, but we may mask the first part of the email address. So you can make out what type of data it is, but you don't know any details behind what data is actually contained in there. Cool. We're going to jump into a demo. I may drop the mic because it's going to be hard to drive my mouse and hold this and focus on the presentation. Cool. So this is what the Immuta UI looks like. I'll jump into it in a sec. So essentially, I don't know if anyone's heard of SCIM before, but essentially it's a security mechanism to control identity replication between different environments. So think about the fact that you may have some existing Active Directory groups, security groups, if you were using Azure. You wouldn't want to go and manually maintain those groups within another tool like Immuta. So what Immuta allows you to do is it creates a synchronization between itself and Active Directory. So if you go and add someone into a particular group, they will automatically gain access to Immuta without any sort of other setup that needs to be done. So this is the landing page for Immuta. So you'll see that we've got a whole number of data sources defined over here. Now, if I go into I'll just go into one of these projects to give you an example. So the nice thing that Immuta does is it's got something called schema detection. So it allows you to watch a specific database or a specific data source for new tables that get added or any metadata changes that happen to existing tables. So there's a background process that you can schedule to run how often you want it to run. And if you add a new table in, the next time you come into Immuta, all the administrators will receive a notification saying a new table's come into the platform, and they can then go and approve or deny that new data source within the platform. So that's a very cool thing, because you don't want to have to manually go and add new tables or modify tables as they come into the system. I just want to open up a particular table here. So we're just going to open up the main patients table for a second. So this is what a data source within Immuta looks like. So it will give you some basic connection details there. So for instance, we're connecting to Databricks. So if you wanted to access that table, you could go and run that query within Databricks to return your data. You'll see there's a tag section over here. And that's that attribute-based access control I was talking about. So for instance, with this implementation, we've got two different areas of the business. We've got healthcare and clinical trials. And certain people in the organization should be able to access healthcare data sources, and the others should only be able to access clinical trials. So we can apply those tags to the tables and automatically control through policies who can actually get access to those tables. If we go into data dictionary, so Immuta is clever enough to go behind the scenes to go and read the schema for all the objects that it's imported into Immuta. So there, for instance, you can see all the columns we've brought in, you can see what the data types are, but more importantly, for instance, patient name, you can see that we've added an attribute that says it's redacted PII data. So obviously patient name is super sensitive. We don't want anyone to be able to see that. So we've got a policy that will then redact the value of the patient name for users who shouldn't be able to access that data. Immuta is also really good from an auditing perspective. So as you can imagine, it's a governance platform. You want strict auditing around who's creating policies, who's adding data sources, but more importantly around who's accessing the data, what sort of queries they're running, and when that data was accessed. So it's very comprehensive. So for instance, if we open up one of these, I'll try to zoom that in a bit. So you can see who the user was that ran the query, you can see what the data source was, and you can see the exact query that was actually run to retrieve data, which is super useful from an auditing perspective. I'll just go into the policies super quickly. So as I mentioned before, we've got data policies and we've got subscription policies. So I showed you guys previously that there was some PII redacted data. So I'll show you what the policy looks like for that behind the scenes. So we are saying mask any columns that are tagged radar redacted PII, except when a user possesses an attribute called full access. So if someone needs to be able to access all of the data, we can simply go and tag them with an attribute called full access, and that'll override this policy. So they'll still be able to see full name and date of birth and all of those things. We've added a condition over here, and that says that the policy should be applied on data sources that are tagged clinical trials. So for any of our data sources, you may have it for customer data, where you may want to apply a specific policy to all of your customer tables. So I'm going to jump in quickly to show you guys what this looks like from a Databricks perspective. How much time do we have left, John?
About 15 minutes.
Cool. And I'll jump back to here. I just want to show this quickly just before I jump into the Databricks demo. So I've been chatting about how everything works from an Immuta perspective, but obviously there's a lot that happens behind the scenes in terms of how Immuta actually integrates with your Databricks or with your Snowflake or any of those platforms. So as I mentioned, it's got SCIM support, which is a system for cross-identity management, which allows you to replicate identities between different platforms. So we've got this Active Directory group called Production Immuta Active Directory. We've got a whole bunch of users in that group, there are 18 users in, and if all we have to do is maintain that group membership within Azure, and on a schedule, those users will be pushed into Immuta. You don't have to worry about anything else. So how does Immuta actually do this? How does it redact the data and apply those policies for us? So Databricks has something called cluster policies. Now, think of a policy as something that, so just to step back a sec, so a cluster within Databricks is something that you use to perform computation. So behind the scenes, a cluster consists of a driver node, and you can have as many workers as you want, depending on how big you want your cluster to be. So these policies are defined on top of the cluster. And what those policies actually do is they do things like defining what Databricks runtimes you're allowed to So just on a side note, Immuta is always going to be a couple of versions behind the latest Databricks runtime version that's supported. And that's obviously because they have to do their own internal testing. They can't just assume that their platform's going to work when Databricks releases a new runtime. So the policy just provides a list of runtimes that a user can choose from if they create a new cluster and they attach that policy. It does things like setting default cluster settings. So I can show you guys a bit more about what that looks like. It sets some cluster initialization scripts. Now, initialization scripts, because the clusters behind Databricks are Linux virtual machines, all the code that runs is Bash. It's Linux code. So you can actually go and write whatever you want as an initialization script. And if you attach that to the cluster, that script will need to execute successfully before the cluster actually becomes available for use. So you can do things like installing Python libraries, you can do things like setting environment variables. The possibilities are endless around what you can actually do in initialization scripts. And a lot of what Immuta does is based on environment variables and that configuration. So how do we deploy this from a CI/CD perspective? So obviously it's awesome that there's a nice UI, but we might spend 2 weeks setting everything up in a non-production environment, and we need to migrate all of those changes across to the production environment. So we've applied some dynamic configuration against the policy. So obviously things like, let me just find an example. So obviously the host name for our non-production and our production Immuta instances are going to be different. So we need that as part of our CI/CD pipeline, so that in our non-production environment, we attach to our non-production Immuta instance, and in our production environment, we attach to the production Immuta instance. We'll come back to the learnings a bit. I just want to run you guys through some of the actual stuff in Databricks quickly. So you'll see that I've got 2 clusters in Databricks. We've got an what we call an ETL and an always-on cluster. The ETL cluster is just a normal Databricks cluster. It doesn't have any policy set up for it. And the always-on cluster is the cluster where the actual Immuta policy is attached. So if we look at some of the configuration, I might go back to the other cluster first. So if we look at a bog standard cluster, you'll see that there isn't anything set up in terms of environment variables, because we didn't have the need for any, and the Spark configuration settings are very limited. If we now go across to the Immuta cluster, you'll see that there's a significant amount of Spark config and environment variables. And these are what Immuta uses behind the scenes to apply all of those policies across your data. So we're going to go into Databricks, and we're going to run some queries. So this is just a Databricks notebook for those of you that haven't seen Databricks before. Right at the top, we set a default language that we want to use in Databricks notebook. That can be R, it can be Python, it can be SQL, whatever language you want to code in. And if you see in command 3, I'll just zoom in a bit, you'll see that there's this percentage SQL. Now that's called a magic command in Databricks, and it allows you to change languages between different cells in Databricks. So even though my notebook is Python, I could put a percentage SQL in and suddenly start writing SQL. Databricks is clever enough to interpret that. So as you can see, I'm currently attached to the always-on cluster. And I showed you guys earlier that the patient name in the main patients table had a policy to redact the patient name. So I'm just going to run this so you guys can see what that looks like. So what you can see is, I'll show you guys, this will make more sense once I run the query against the other cluster. But you can see that because our policy has applied a physical string redaction for the patient name. So in the policy, we've actually said, replace the patient name with the word redacted. So if I now run a query to check how many patients there are where the name is redacted, it's going to say every single patient record in the database has a value of redacted. So I couldn't, without having access to the data, I can't actually do any analysis around patient names that may be null, or look for specific types of patient names. So it redacts all of that data from you, so you don't have visibility into any of that. So as we can see there, I want to see how many patient names are null, and it's returning nothing. It's saying that there's nothing there. Now, this might be a little bit technical, but Spark is very similar to any sort of other processing engine where it generates an execution plan when you run a query. So it generates a logical plan and it generates a physical execution plan. So I'm just going to zoom in over, where is it? Over here. So the way Immuta actually works is when you run a query in Databricks, that query plan gets sent to the execution engine for execution. Now, what Immuta does is, you'll see it's calling an Immuta constant masking expression. So it actually intercepts that query before it gets to the Databricks processing engine. It applies any of that masking that it needs to do, and then it returns the results to you. So if I was to go and run this against my normal ETL cluster, which doesn't have any policy or anything attached to it, I'll show you how different the results are. So now you can see that it's telling me that none of the names have been redacted. And I've actually got quite a lot of invalid names. Of the over 100,000, I've got 96,000 where the patient name is actually blank. So if we wanted to see that data, we could run a query, and unlike the previous query, it's returning all of the data to me because I've got access to everything. You'll also notice that the execution plan doesn't mention anything about Immuta in it anymore, and that's because the Immuta policy hasn't actually been applied to this cluster at all. I'll quickly chat about Databricks SQL 2. So for those of you that have used Databricks, Databricks SQL is an interface where Databricks tries to make it easy for data analysts to go and run their queries within the Databricks platform. So you can only execute SQL statements. You can't run any of the other languages that are used in traditional clusters. But it provides a really nice interface where you can go and write all your scripts. You can create visualizations within Databricks SQL too. Immuta does have preview support for Databricks SQL. And because the underlying architecture for Databricks SQL is very different, Immuta has to change their approach slightly. So on a Databricks SQL compute node, it doesn't actually create an execution plan. The underlying infrastructure is very different. So Immuta can't intercept that plan because it doesn't have access to it anymore. So what Immuta does is they actually create dynamic views that sit on top of your data. So rather than physically intercepting the plan to change the query, what it does is, I'm just going to copy this up quick. Full code formatting in Databricks. So you'll see what it's actually doing now is it's still querying the same underlying table, which is my main patients table, but it's applying these case statements around the data. So Immuta stores which data sources you have access to within a table in Databricks, and it also stores all the details around those policies. So irrespective of who's accessing that data, those policies will be dynamically applied based on which data sources you have access to. So if we look at the structure of the object itself, so you can see it's a view, and there's the view definition that I just showed you guys. So what Immuta also does is it creates a view that contains details around who you are as a person within the Databricks interface. So it's saying there who I am. I don't belong to any Immuta user groups. I have authorizations, and those are the ones I have. And if I scroll to the right, you'll see what data sources I actually have access to. So this is dynamic based on every user that's logging into Databricks and running queries. So you can dynamically query the same view, but dynamically apply that security on top of your data. Cool, that was it. Sorry, hard slog. I know governance is hard, folks. We've got to do it at some stage though. Do you not have any questions? Yeah, perfect.
In terms of the traditional data governance activities, in terms of data stewardship and having a data steward or a business user firstly defining attributes, the definition of the attribute, and then also defining the policies. Is it easy enough for a normal business user to do that?
Yeah, so it's super easy within the Immuta interface itself. So if I just go to the governance section and I go into tags, so if there are any new tags I want to set up as a data steward, I can go in there and set up a new tag. And then on the data source itself, so say for instance, I wanted to tag all of these tables that I have with a particular tag. They make it super easy to do that from a user interface too. So you can multi-select all tables and apply certain tags. You can also automatically apply tags to objects based on that schema detection I spoke about earlier. So if you want to tag all of your tables in a particular database with an attribute, if it detects any new tables coming through from source, those will automatically get the new attribute as they get added into Immuta. Cool? No side on that? I'm out of time.
How do you cover the security for the Power BI or data sets or on the visualization end?
So on the Power BI side is where it gets very tricky, because if you use import mode in Power BI doesn't know who has access to what anymore, and it doesn't respect any of the governance that's been defined in any other tool. So what we actually do is we use direct query in Power BI. So the Databricks performance, look, any cloud tool you use is not going to have fantastic direct query performance. And if you're loading a dashboard with 100 visuals on it, it's going to take a long time to run. So fortunately, the customer was very keen to do very structured reports that they wanted to export to PDFs. So we actually used Report Builder sitting on top of direct query data sets defined in Power BI. So that then means that any user within business can go and run a Power BI report. But if they don't have access to see patients' details, they're just going to see whatever's been defined in Immuta. So they may see nothing or a mask or a redacted value.
I had a question from the chat.
Sure.
Can you define these rules and policies through code?
You can define them through code. So I'll just show you guys quickly. So Immuta's actually spent quite a bit of time on the API, and the entire UI you see is actually hitting the API directly. So any of the endpoints or anything that has been defined inside of this area can be defined through your CI/CD process. So obviously, if someone's adding a new tag or adding a new policy, you want that to go through your traditional review process before it gets deployed out into any other environment. So you could give them access to define it in the UI for the non-production environment, and that could then feed in through your traditional CI/CD process to be peer reviewed and deployed out into your production environment. Okay.
I know you work with Databricks, but
Yeah.
Can this Immuta be over something else, not?
Yeah. So if you look at, I
Databricks?
just want to go back to that slide quick.
Just an example.
So I will drill in over here.
Oh, yeah.
So
Yeah.
anything you see under the compute side is any compute that Immuta can run on top of. So we've got AMR, a lot of tools within AWS, Google BigQuery, Azure Synapse. Majority of the platforms you're going to run from a big data processing perspective are supported from Immuta. Oh, sorry, Matt. Did you want to grab a photo there? There you go. Any other questions? Yeah, go, man.
Last question. We use the DBT along with the Databricks and Synapse.
You can use DBT. We haven't used it personally. I personally have a preference. I'm a hardcore SQL guy. Like I've written SQL my whole life.
Yeah.
The thought of using a tool that is generating SQL on my behalf makes me super uncomfortable. So I've looked at videos of DBT. I've played around with it, but I haven't used it. I do know of other customers that are using DBT on Databricks with Immuta and it works well.
Great, awesome.
Cool. Thanks, folks.
Test.
I think the microphone's a bit funky.
All right. Hello, Matt. There we go. Thanks, Dave. Next up, we have Ben Zil. Let me just get my thing up. So, a bit about Ben Zil before we jump in. And yes, feel free to grab another drink, some water at the back if you wish. Ben Zil is the co-founder of Databricks.io. His formal qualifications include a graduate degree in actuarial science, a postgraduate qualification in math, statistics, and advanced analytics. Very math heavy, I have to say. And he has been doing all things data for the past 25 years. All right. Over to you, Ben Zil.
Okay. Is this okay? Everyone can hear me? Okay. So why the chair? Normally I'm not very comfortable in front of people speaking. That's the first reason, but I've spoken quite a bit in front of people. The other reason is I walk around a lot when I speak, and when I have one of these things go in and out. So it's easier for me to sit down and hold it on my lap. And then often when I speak, I'm not invited back again. So hopefully you guys are going to be good judges of that. So I'm just going to move a little bit. I mean, having a shadow. Is that good? Yeah. Okay, so I think one of my team members asked me why this title. So that's why the book is here. Stephen Hawkins. I stole the title from him. So shout out Stephen Hawking, very smart guy. And the title's a bit misleading because I'm going to speak much more about the career of a data engineer than I'm going to speak about ELT and ETL. I think so. When I speak, keep on focusing on the kind of the main words that I use, the skills, because I'm going to speak about data engineering way back and data engineering today, and see if you can pick up things that we used 30 years ago that's still being used today. And there's a common theme there. Just a quick one, David and I worked together in South Africa 12 years ago for the same company, and we didn't coordinate it at all, so it's a coincidence. And you get two types of South Africans. The one is David, which is an English South African, and then you get my type, which is a Dutch or Afrikaans South African, so you'll find the accent very different, so hopefully you guys can understand me. So I'll start with something which is just a bit of a brain teaser. I'm going to let you just soak that in for a while. And for me, the message here is in data engineering, there's a lot of things that we use today that was invented in the 1960s and 1970s and is still prevalent in our world. But we don't always understand why we're using it, the constraints, and kind of the design decisions that were made. But if you look at the space shuttle, and even that's old today, that used to be a new thing. If you look at the space shuttle, the width of the rocket, of the side rocket, is just a little bit more than 5 foot 8 inches and a half. And the reason for that, if you work your way back all the way to the beginning, is in the Roman times, the chariot of the Roman chariot was exactly, the wheelbase was exactly that. And because they were driving up and down in Europe, they were creating these big paths with grooves in the roads. So the farmers rapidly realized that they have to make the wagon wheels the same wheelbase, otherwise they have to keep on changing the wheels. And so the wagons became exactly that same width. And when they started building railway tracks, because they had to use wagons to build the railway tracks, what's the width of today's railroad tracks? Exactly that. And so when they decided to build a space shuttle, they had to get rail cars to bring in the space shuttle equipment. And so the rocket is just a little bit more than that. And it's a little bit the same in data engineering. There's a lot of things that we use today that was developed a long, long time ago. So more things change, the more things stays the same. And so the theme of what I'm going to talk today is really about skills and kind of those core skills that you need and to have prevalent, which has been in existence for a long, long time, and not focus too much on the shiny things in our business. I mean, there's almost a new tool on a daily basis these days, and it's really impossible to keep up. So I think I told the story to a few people that's worked with me, so I apologize if you had to hear it again or suffer it again. So I'll do a bit of a quiz. I'm glad about the age profile in the room. So I'm going to first ask you, who are these two gentlemen? First gentleman, do anybody know who he is? Yes, Shane?
It's Ralph Kimball.
That's Ralph Kimball. And on the other side, Shane, you can't answer again.
Bill Inman.
Bill Inman, yes. So those two individuals were the fathers of data warehousing. So most of us have to be thankful for the early work that they did in the 1970s and 1980s on data warehousing, data engineering, business intelligence. Without them, we wouldn't have, well, it probably would have still manifested, but maybe it would have looked quite a bit different. But those two gentlemen were really the beginning of data warehousing, business intelligence. And in the beginning, when I started, it was called decision support. The word data warehousing didn't even exist. So you look at my diagram, I'm not sure if you guys can see, we started with the word decision support, because ultimately, what's the purpose of data warehousing? It's to support decisions, right? And so I've got the punk, 1980s, 1970s. We started with decision support. We graduated to Nirvana, not the place, the band, in the 90s, and early 90s to mid 90s. And then it was called data warehousing. And then we graduated to M&M. I can't see the other one. And then we called it business intelligence. And that just shows my age. If you put another modern artist there, I wouldn't even know who they are. And today we've got data science and advanced analytics and all kinds of other names. But really, that was the progression of our world. In the beginning, in decision support, you had one person doing everything. I was that person. I'll talk about that a little bit now. So this is starting to sound a little bit like one of those dad or grandfather stories. Way back in the day, a hamburger was 10 cents, blah, 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 and you start to roll your eyes. But please keep going with me. There's a moral to the whole story. So in my very first job, and I studied as an actuary, so the normal way of getting into a role in a business as an actuary, become an actuarial clerk at an insurance company. And in my days, you had to go through all the different departments. I started in the mailroom, worked my way up, finally ended up in the actuarial department, and they put me immediately in the claims area of life insurance. And so all my aspirations of being an actuary was killed there very rapidly, because if you work in claims in life insurance, the only thing you deal with constantly is death. Now, I'm not saying it's a bad thing, I'm just saying I couldn't stomach it, so I was always forever looking for another avenue in another area in the business. And the head of the IT department mentioned they're going to build a thing called a data warehouse. And they've invited a guy called Ralph Kimball to come do a talk, I don't know who's Ralph Kimball, I don't know what a data warehouse was. But one thing I knew is it wasn't claims and it wasn't life insurance, and I was the first guy to put my hand up. And then they asked us to apply to this department. And I was the lucky one that got picked. And I walked into a room, and there was this guy called the decision support manager. I changed it to data warehouse manager just to make it a bit easier for everybody. And I'm going to try this, and if I blow your ear, I'm sorry. This is what he told me, very first thing. Hey, you guy, come here. And that was in the 1990s when political correctness wasn't even a term. And this is the first thing he told me. If you want to be a data warehousing consultant, then these are the things you need to learn. So learn SQL. I don't know what SQL was. Okay, I'll learn SQL. Learn natural database. And does anybody put up hands who knows what's natural database? There is one up here. There's one here, and the lack of hair tells me why you know. Same here. And the reason we had to learn natural database is because the insurance system was developed in that language /tool/4GL language, and so it would make sense for me to learn how the application works. So that was the next thing I had to learn. So they sent me on a course for SQL and a course on natural database. Next thing they said, learn Ralph Kimball. I knew what that was because that was the guy who did the talk at our office, and I started to understand a little bit about design of data warehouses. And then today we have a role called a business analyst, but didn't exist in those years. It's to figure out what the business wants, figure out where the data will come from, design and implement the model, build the ETL. The word ETL didn't exist. Build the stuff that gets the data and put it in the database. Learn Sybase, which was a database. Who knows Sybase? Hey, David, he would know. And then keep it signed off. And that was in those days, as a data warehousing person, you were everything. There was no such thing as data engineers or analytics, visualization was all kind of, and he's shaking his head because he remembers those days very, very vividly. And so often when an area develops and matures over time, areas of speciality starts to pop up. And that's a very natural kind of progression when you look at technology. So again, remember the little words. So what skills do you have today? That's on this slide. So I think most of you guys will have at least a view on SQL. I have SQL skills. I'm not going to ask you to put up hands, but that's an important lesson. So what did the technology landscape, and I really struggled to find the old logos. So I hope you guys appreciate the effort. But in those days, these were the typical tools, and there's many more. So, these are kind of the typical tools that was in the data warehousing space. Originally, we'd write a lot of SQL, and in those years, in that first role, after the third year into the role, I realized we can't keep on writing SQL. It's not sustainable. The subject matter expert leaves. The main guy who knows what's going on leaves. It's not well documented. And then we stuck. And so we realized that, well, maybe there's a tool out in the market that can do all of this ETL stuff or integration stuff that's driven by configuration and parameterization. It does deployment. It's got security. And there was two primary tools that started to become very prominent in the market in the late 90s, which was Informatica and DataStation. Both of them are still around today. Those are the kind of the primary two tools. There were others as well, but those were the two primary ETL tools in the market at that point in time. And from a visualization point of view, Cognos and Business Objects, which is both still around today, were kind of the primary visualization tools. But the model of moving data from left to right was very much ETL, because all of the equipment hardware was on site, and all the operating system logic was on site, everything was running on site. And so it made sense that you could extract information from a local server in a database or files, transform it in memory, and then load it into the target database. That was the very typical model. There's some exceptions. I think in the mid-2000s, Oracle came with a reference architecture that first spoke about ELT, but the ETL pattern was the standard pattern because the ETL tool, which sat in the middle, could run on-premise, what we call bare metal, in memory, could do a lot of the work, and you didn't have to persist the data, you could do it all in memory and it would load it on. And that was I like my 1990s and 2000s logo, but that's very much how we did it in the 1990s. Again, SQL was absolutely prominent in those years. So SQL was the language that sat and behind these ETL tools that made it live and breathe. SQL was one of the, and SQL has also got a long history since the 1960s. So there's not just one SQL, and not all SQLs are equal. But SQL as a generic standard was prevalent in all of these tools. So if you look at the critical skills of a data engineer, which didn't exist in those days, let's call them the data warehousing guy, the critical skills, I'm going to quickly run through that for those years were SQL programming, familiar. SAS was pretty big in those days. Bash scripting, so actually writing command line commands in Linux or Unix, and command line, which is kind of your DOS-based command line, those are critical skills. ETL tools, so you could not get a job as a data warehousing data engineer if you didn't know one of these tools. First question, do you know Informatica? How many years experience do you have in Informatica, DataStage, Talent, Tento, any of those tools? They were critical on your CV. You need to, the second thing they would ask you, do you know Ralph Kimball? You'd say, no, I don't know him personally. They'll say, okay, do you know how he designs data warehouses? And that would be critical to getting a role as a data engineer or a data warehousing person. You needed to know the databases. So I've got the raft with all of them there. But depending on the customer or the employer, they'll say, do you know Sybase, Oracle, blah, blah, blah. And you would say yes, and that would qualify you. And then you really need to know hardware and operating systems. So I remember my first few roles as a data warehousing person, that was like, okay, let's build a server, let's configure the operating system. All of that was also part of our role. We were very savvy in terms of hardware and operating systems, and I can still claim that I've built some of these things, from the bottom up, from zero. I had to build a data warehousing server. So just to drill into the old tools, this is blurred on purpose. I couldn't find a better picture, in inverted commas, of one of the ETL tools, and that's typically what it looked like. You had data moving from left to right, and part of your role was to go like this, match, 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 and I think eventually Informatica found a way of bulk matching things. But there's not a lot of development in here besides that in the back, and David said he's allergic to writing SQL. This would generate a lot of SQL in the background, and it would have its own scripting language. Like Informatica had its own scripting language, and you would do programming in that language to transform data. And so in those days, it was really SQL heavy. It had a bespoke scripting language. And again, think about what you're doing today. Tool knowledge was absolutely critical. It was an end-to-end solution. You didn't have to use 4 or 5 solutions. That was one solution for data engineering. It was on-premise, and people were typically all-rounders. Okay, I don't want to ask you these names because people would typically not know these names. But there was a big change in the kind of 2010, maybe a little bit before that. And these people are not the people who invented the cloud or built the data lake. They were the people who coined the term for the first time. So James Dixon coined the data lake, and Sean Sullivan, and I know Sean, I just put his own old picture in there because I think it's funny when he had the frail and now he didn't. Now he's like all modern. But he coined the term the cloud. And this brought a major change to how we potentially could approach a data warehousing solution, and also from a data engineering perspective. So let's talk a little bit about ETL versus ELT. So I think most people that's data engineers will understand the difference. In the old days, we would first extract the data, transform it typically in memory, and then load it into wherever, into the data warehouse, already structured or dimensionally modeled. If it's not a dimensional model, it could be another model, third or more formal, a data vault model. But that would be typical pattern. The cloud pattern, and I put in there boring because I thought this would potentially be boring for everybody. The cloud pattern typically is you extract the data, then load it, and then you transform it when it's already in the cloud. And most of the tools function that way. So the idea is that a lot of the transform logic sits within the cloud instead of sitting in this kind of middle layer. And it makes practically sense because you want to lift the data from on-premise potentially, get it into the cloud, and then do the heavy lifting in the cloud. We've got all the CPU and all the hardware that you need to be able to do things efficiently. So the landscape has changed dramatically from those old days. The data engineering, and that's, I've left out, please, if I've left out your favorite tool, I apologize, but that's the world today. We've got the big cloud vendors, Google's, the Azure's, the AWS. I played with Alibaba the other day, Databricks, Snowflake. So the world now today is much more a cloud-centric world, even though all of those old vendors still exist today. So some of those kind of logic that they have is still good. Informatica's got a cloud offering, as does DataStage, as many of these other tools. Cognos has got one as well. So that design pattern is still valid. It's just within the cloud brought other complexities. So cloud vendors have got a different approach to some of these challenges. So what's the critical skills for data engineers today? And again, if you think back to the original slide, SQL, Python, R, Bash, PowerShell, there's probably quite a few others. I've got quite a few others. That's my favorites, but you'll see SQL popping up again and again, SQL. And a scripting language, whether it's Python, R, or some language to be able to do orchestration, transformation, or some sort of mechanism that you want to do that's outside of the ability of the tool. Tools have changed, and now today, if you go onto the internet and you Google data engineering tools, you can spend days just going through all of that. A lot of them are Python-based, SQL-based tools. That's kind of the core languages that sits within all of them. Data warehousing design is still critical. I think, dream that you don't have to design your data to analyze it is really a dream. You still have to be able to design a data warehouse. You still have to be able to model data. You still need to be able to transform, embellish, check data for data quality. So data warehousing design is still critical. Databases has changed, and I normally throw them in three buckets. There's structured data, semi-structured data, and unstructured data. Today, databases can cater for all those types of data. In the old days, we were primarily focusing on relational data. And another skill to have is cloud architecture and containerization. I don't think you can do data engineering, or maybe you can, but if you want to do that as your career and as a career progression, you need to get good around cloud architecture and also around containerization, because it's also embedded in a lot of the technologies we use and simplifies things like data ops and CI/CD. Okay, so what has not changed much over the 30 years? Firstly, SQL, Bash, and command line. That's been around since 1960, and we're still using it. And remember my little train track analogy with the little cart? SQL is really our train tracks. It's really our Roman chariot. ETL scripting has been replaced by Python and R, and in the future will be replaced by other languages. And so, and again, I've been doing this for 30 years. One thing I can guarantee you, the tools will change and the languages will change, almost definitely. Data warehousing design is still around. Ralph Kimball is still spoken about often, and most tools still use that from a visualization perspective, exploitation point of view. Paul Inman is still around and is a big speaker around the lakehouse concept. He talks a lot about it. He wrote a little book, even though he's in his 70s, so his ideas are still prevalent. And Dan Lindstedt, who's the thinker behind Data Vault, it's the only new kind of modeling technique. He actually was a student of Paul Inman. And I heard the conversation between them and said, he asked Paul, how do I become wealthy and famous? He said, come up with your own data modeling technique and write books about it. And that's a true story. Anyway, databases is pretty much the same. Relational databases structurally are similar, but obviously we have graph and SQL today and other things. Most traditional ETL tools still exist today and have a cloud offering. It tells me that those patterns are valid. The design patterns behind those tools are still valid. And often I go back to those tools and say, what did they offer? And then I look at the new tools and go like, what is missing? Because those tools have a really long life in the industry and was very successful in the pre-cloud world. And roles today are much, much more specialized. Where in the beginning of my story, I was supposed to do everything. Today you have data engineers, data analysts, data visualization experts, and in the future you'll have people that specialize in architecture, cloud architecture. I think the team, as this thing matures, will get more and more roles. So as an individual, you have to work out where is my passion really? Is it data engineering or is it somewhere else? I've been doing data engineering for a very long time. It's not because I'm a boring individual, it's because I love what I do. And so you have to really, as an individual, find what you really love. And if you think about it, moving data from point A to B, you always have to question your sanity. Why would that be interesting? What makes it interesting is the challenges around connecting to really complex data sources and complex transformations, understanding the business, becoming a subject matter expert in a specific vertical in the industry. All of that stuff drives you. The tools, not so much. I think what's really critical is that you have to stay very close to your core skills. People often ask me, if I learn Snowflake, will I have a job in 60 years? If you live that long, I would say no, stay close to your core skills. Understand design, understand analytics, understand architecture. SQL has proven that it's a valid skill to have. Learn a language, today Python, but learn a language that teaches you about object orientation or design, or a language that teaches you more than just a language. I think that languages would change as well. So New Kids on the Block, that was really a band, and that was the band. So if we look at what's kind of new in the industry, from an architecture point of view, I don't know if you guys have heard of data mesh architecture. There's quite a bit of chatter around data mesh architecture. Whether it's valid or not, it's worth looking into, because it is a new way of looking at doing analytics in a business. It's a little bit the data lake, the data warehouse, but pervasive throughout the business. It's a different approach. So there's a data mesh organization. I would recommend that you have a look. Data governance, thanks David for setting that up for me. Data governance is becoming more prominent, and that's a natural cycle. As soon as people build data lakes, data warehouses, things mature, the very next question is, okay, how do we govern this? Who's the owner? How do we make sure the data quality is correct? And we're really now in a little bit of a cycle where data governance, from a technical perspective, is becoming more prevalent in the forefront. And then tools improve and will consolidate, and that's just been true forever. Tools will get more. I'm always looking for who's going to be the winner. So you can always do a bit of a betting thing. It's like which tool is going to survive and which is going to be the next big tool. There's going to be new languages. There's already Go, Julia, Rust. I've been doing lots of work in Rust. And the reason for that is performance improvements, wider set of libraries available. And it's funny how these languages evolve. But when I did my Java certification, I thought I was set for life. And then things like R happened. I worked with SS+, then it became R. Languages will change, but the concepts behind programming doesn't change that much. And at some point, you've done so much of that, when you have to hop into a new programming language, it's all the normal concepts are still there. It's easy to move on to something new. So it's good to learn different languages. Don't think that one language is going to be the end of your career and that's going to be it. Even though COBOL is still around, people have had very, very long careers in that space. And then new projects, DBT, Meltano, Daxter, Prefect, and there'll be many, many more. So as a data engineer, if you love data engineering, you almost become a tool collector as a life thing. At one point I don't know if you guys floppy drives or what it's called in Australia, but I had a box full of tools that I've downloaded, harvested, I don't want to say the word stolen over the years, purely because I was interested, what makes this tool better? What makes this tool more attractive? So I would encourage you not to get stuck on one thing. Get exposure to as many of those tools. Often that ends up where you want to build your own tool, and then 6 months later you're going to go like, it's never going to happen, but because you don't have the time capacity or the intellect or a combination of all three. But it gives you the opportunity to see what's good and what's bad. And often when you walk into a new employer or a new customer, you want to be able to stand up and say with confidence, I don't like this. Like David said, he doesn't like tools that write SQL for him, and he's got a valid reason for that. Each one of us needs to be able to make those decisions where we can walk into a customer and say, or an employer, I'm a consultant, I always talk about customers, I apologize. You need to be able with confidence to say, I love this because it's better for this reason, blah, 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 blah. Or I love this because I don't like it, it's worse because of that and that and that reason. And that's how the convergence happens. That's how people actually, some of these tools get eliminated. So I think that the lesson here is, as a data engineer, stick to your core skills. Learn as much as you can. Love what you do. If you don't love what you do, don't do it. Do something else. But also take the opportunity to go back in the past and see where things come from. Don't just look blindly into the future. That's it. Any questions? I'm going to run around with this if you have questions, because no guys at the back couldn't hear anything. Any questions? That's it. That's how I like it. Oh, there you go. Jeremy, you good?
You mentioned a lot about the skills. What about some of the soft skills? So curious what your opinion is on, personality, communication, that sort of thing. Soft skills.
You're asking somebody with a very low EQ. But now soft skills, it depends on your role. So and also your personality. Some people do not enjoy to be in front. Some people enjoy being the technical expert, and I totally respect that. But you'll always work with people, and in the data engineering space, that's very true. Sometimes with your own team, you get, in my opinion, I've got lots of opinions, you get two types of extrovert. Some people, it's an extrovert within their team, but an introvert outside. So I think you need to understand your own personality and your own passions and where you want to take your career. But soft skills are absolutely crucial, and working with stakeholders is a really crucial part of that. You need to be able to have a meaningful conversation with somebody to understand the requirements, what they want, and also then be able to articulate that in a simple way back to them to confirm what they want. So there's lots of soft skills that you need, but it depends on your role. So I've worked with people that's absolute geniuses, and they cannot make eye contact with anybody, and it doesn't mean they're any less than anybody else. They built software and things that blows my mind, and I think that, if you ask them what soft skills did you ever pick up, it's like, I can now have a conversation in the lunchroom with somebody without being embarrassed, where other people want to be in the front and they want to design, talk about architecture, passionate about what they do. I believe very much in a team that's got a variety of skills. It depends on where you want to land yourself, I think. Any other questions?
Yeah, we are all here in a data engineering forum meetup. Okay. I wonder if you have the history of when it started, data engineering, because it's not very old, very new.
Yeah, the word started on
Data engineering.
The data engineering word was coined by somebody at IBM, and it was in, I can't remember the name, but it was in 2010. Yeah, so it's a pretty new, and I think there's two words that you can tag anything onto and come up with a title: engineering and architect. Yeah. You can be a data architect, a data engineer, visualization architect, visualization. There's two words that's probably very widely used. I think when you move data from a place to another place, you're a data engineer. Or today, and maybe in 5 years you'll be a data shuffle arounder person. I don't know.
Data mover.
A data mover. I think the title is going to change, and it will be some consulting company like Databricks who comes up with a fancy new title. And I mean, at Databricks we don't have these titles. We call things people like data masters and things, and maybe that people love that and they'll go with that. I don't know.
So why do you have this IO spot diversion?
IO input output.
Okay, but it's just to make fun, data diversion.
Yeah, no.
No?
I should put an N at the back. It's clever. Yeah, any other questions? No? Sorry for boring you with history. And I hope they do invite me back. Just last little story. When Jonathan said, would you do a talk? And as soon as you get a message back within a millisecond, you should worry, Jonathan, next time. Maybe consider that as a bad sign. Okay, thank you, everybody.
Thanks, Manzio. That was awesome. I'm going to change my LinkedIn title to Decision Support Engineer.
Go to the roots.
All right, well, thanks everyone for coming down. That's all we have for tonight. Feel free to stay back and mingle around and get to know everyone else. But yeah, have a very good evening, and thanks you all.
You know that